Welcome to This Explainer. So today, we're cutting right through the buzzwords and looking at a highly practical playbook for hospital owners who want to move their operations from messy, fragmented data all the way up to predictive AI. If you've ever felt like healthcare analytics is just this massive money pit of overpromised and underdelivered hype, well, you're in exactly the right place.
Right off the bat, I want to share this quote to kind of set the stage. The framework we're exploring today is not theoretical. This isn't some fluff dreamed up by a software rep trying to sell you a massive license. And it isn't from a data engineer totally detached from clinical realities. We are approaching this from the messy, realistic perspective of an actual hospital owner. This is all about solutions that actually survive contact with a chaotic morning outpatient department and a very real pharmacy stock register.
Okay, let's dive into this. Here's our mental blueprint for today. We're going to start with the hospital data reality, then build up to layer 1 with the dashboard, tackle the unglamorous data pipeline, get into layer 2 with practical AI, and wrap it all up with a concrete implementation roadmap.
All right, part 1, the hospital data reality.
You know, the biggest myth in healthcare analytics is this idea that your hospital just has one neat, centralized database. I mean, it doesn't, right? Your reality is basically a bunch of completely isolated data islands. You've got your outpatient department, the pharmacy, the operating theater scheduling, HR biometrics. Now, they all generate structured data, rows and columns, but they speak completely different languages and they update at totally different speeds.
So the real problem here isn't a lack of structure, it's the fragmentation. Think about it. A patient named John Doe might show up as J. Doe in the pharmacy system. It may be John D. over in billing. Trying to automatically figure out if they're the same person? Good luck with that. Untangling this mess is literally the unglamorous 70% of the work. And here is a hard truth we need to face. Absolutely no AI vendor is going to come in and do this plumbing for you. You have to build it.
Which brings us to part 2, layer 1, the dashboard.
Building a working dashboard is honestly the ultimate forcing function. Once your staff actually sees their data visualized every single day, you'd better believe they start entering it more cleanly. But which tool do you use to build that habit? Well, Looker Studio is absolutely fantastic for early-stage needs because it connects instantly to Google Sheets, completely for free. But if you need board-level financial roll-ups, like say blending cost per bed day with pharmacy consumption, Power BI brings some serious, heavy-hitting capabilities, though it definitely has a steeper learning curve. Metabase, on the other hand, is kind of your hidden gem if you need strict, self-hosted patient data privacy.
So, the big takeaway here? You don't have to pick just one massive tool for your entire hospital network. Pick the right tool for the specific report. Need a quick departmental tracker? Go with Looker Studio. Doing a multi-branch financial roll-up for the board? Power BI is your friend. Flexibility is absolutely your best asset here.
Moving right along to part 3, the unglamorous data pipeline.
This hidden plumbing is exactly what determines if your shiny new dashboard is still being used 6 months from now or if it just gets completely abandoned. Let's look at how this pipeline actually matures. Level 0 is pretty fragile. It's just a manual daily CSV export. It's totally fine for the first 60 days just to validate if a report is useful, but it breaks the minute someone goes on vacation. Level 1 automates things a bit using simple script glue to write data directly into Sheets. But Level 2? That is the actual goal. A proper automated nightly pipeline feeding into a centralized warehouse like BigQuery or Azure SQL.
And listen, as you build out that warehouse, data governance is absolutely non-negotiable. If you're putting together a dashboard just to track daily footfall or revenue, that dashboard only needs numbers, dates, and branch codes. It literally never needs the patient's actual name, their phone number, or their exact address. You have to tokenize or exclude those patient-identifiable details to ensure strict privacy compliance. A good architecture is, at its core, a privacy-first architecture.
All right, so this brings us to a really critical pivot point. Everything we've talked about up to now, the pipelines, the dashboards, that's all descriptive analytics. It answers questions about the past, right? Like, how full was the operating theater last week? That's necessary for sure, but it isn't sufficient. To really drive down operational costs, a hospital has to transition into predictive analytics. We have to stop just reacting to what already happened and start preparing for what's about to happen. Questions like, how many patients are going to walk through those doors next Tuesday?
Which leads us perfectly into part 4. Layer 2, Practical AI.
Now, what's really interesting about this is how we need to completely strip away all those sci-fi Hollywood expectations of AI in healthcare. You don't need some massive, glowing, sentient chatbot.
Practical AI is actually remarkably boring, in the absolute best way possible. It's really just a scheduled statistical model that predicts a number and then writes that number as a brand new row into the exact same structured table your dashboard is already reading. Your dashboard doesn't even know that a machine learning model produced that row instead of a human. Let's ground this in everyday reality. Here are 5 incredibly practical ways this gets used. First, predicting outpatient no-shows so your reception can safely double-book high-risk slots. Second, forecasting daily footfall, like anticipating a big spike in pediatric cases on a Tuesday. Third, adjusting your staff roster based on that exact predicted demand. Fourth, forecasting pharmacy demand per SKU so you literally never run out of critical antibiotics. And fifth, predicting expiry-driven wastage so you can redistribute drugs that are nearing their expiration date before they become a total financial write-off. But we do have to be pretty precise with our terms here, especially when it comes to staffing. There is a vital difference between predicting demand and actually optimizing a roster. Predicting how many nurses you're going to need next week based on footfall, that's machine learning. But assigning specific nurses to specific shifts without violating labor laws or rest rules, that's what we call a constraint satisfaction problem. It's rule-based math, not machine learning. So please don't let a vendor charge you some massive AI premium for what is basically just a basic rules engine.
So putting it all together, here's your complete end-to-end stack. Number 1, the source systems. Number 2, the pipeline. Number 3, the dashboard. And number 4, the AI layer. Keep this mental model locked in, because the next time a vendor pitches you some revolutionary all-in-one product, I want you to pull up this exact framework and ask them exactly which of these 4 layers their product actually occupies. Trust me, it will save you a ton of time and money.
All right, final section, part 5, the implementation roadmap.
So how do we actually build this stack in the real world without completely failing? Well, here is your chronological battle plan. Phase 0 is all about auditing what data you actually have. Phase 1 is proving value with just a single dashboard, solving one major pain point, like pharmacy stock, for example. Phase 2 is scaling that into a proper data warehouse. Phase 3 is where you finally introduce your first AI prediction. And Phase 4 is when you scale and govern the whole system. The absolute golden rule here, you cannot, under any circumstances, jump ahead to Phase 3's AI until Phase 1's dashboard is actively used and trusted by your doctors.
Because if you try to skip steps, you are guaranteed to hit these common failure modes. Things like building dashboards that drive zero human action, or picking your software before mapping out your data islands. Treating AI as an unexplainable black box is fatal because non-technical doctors simply aren't going to trust a system if it can't explain why it flagged a patient as a no-show risk. And finally, waiting until Phase 4 to even think about patient privacy instead of just building it in from day 1.
Which leaves us with this final, pretty stark question to consider. If you rush to implement AI without doing that unglamorous 70% of the integration work, without building the pipelines and the dashboards first, are you just automating the delivery of wrong answers faster? Solid, clean, foundational data is literally the only path to true operational AI. Build the plumbing first and just watch how it completely transforms your hospital. Thanks so much for joining me for this explainer.